Okay, good morning, everybody. Afternoon, perhaps, if you're watching from Europe. It's always great and a pleasure to see you guys on episode 31st of our MakerBot chat series. Hi, my name is Felipe, creative director here at MakerBot. And today we have an interesting one. It's all about the Labs extruder. We've had a similar one before, but today I'm going to take you through the actual process of changing the nozzle. So we'll be doing like that step-by-step process. As you guys know, we've just launched metals, right? Well, specifically one metal, BASF 3116L. That's a whole name. It's a stainless steel metal that you can print with the method. However, in order to print it, you will need to use the Labs extruder. So what I'm going to do today, wrong title card change. Here we go. What I'm going to do today is actually show you the differences between like a regular model extruder and the Labs extruder. And then we'll talk a little bit more about the different materials that you can use with the Labs extruder. The Labs extruder, it's not only good for or meant to be used for printing metals on the method. So I have my method behind me, if you guys can see it. It's not so much about the printer, but if you have any questions about the printer, you can definitely ask them. But today we are going to be focusing on the extruder, right? So I'm going to talk a little bit about these different materials, the fact that they can all be printed with the Labs extruder, and specifically also, well, not only that, but they can all be printed with the Method printer, right? Both Method and Method X will cover the materials that I'm going to be talking about today, except for one. And then I'm going to show you how to replace the nozzle on your extruder. These extruders come with a set of two nozzles, which you can change if you have any issues with it. Usually what I've seen happen a lot is that the nozzle can get clogged if you change a lot or toggle a lot between different types of materials. Let's say that you jump between ABS and carbon fiber, or nylon carbon fiber, since they have a little bit of a different or differences in melting temperatures, you can see issues if you continuously jump back and forth between these filaments, and that's where the extra nozzle in the package comes in. I'll start really quickly doing a recap. And by the way, thanks to Alejandra, who's behind the scenes, sort of capturing all of your guys' questions. If you have any questions, just post them up in that right-hand chat box in the YouTube, and we'll be happy to answer those. If you're watching this as a repeat, so not the live session, you can definitely reach out or leave the questions that you have in the comment section down below, and we'll be happy to address those too. But I wanted to do a quick recap of the materials that we are currently offering with Method, right? There's 25 of them right now. It's quite a lengthy list, and I think that it's a really impressive one, specifically because I've used all of them, like all of those materials I have used, and not only used, but in this particular printer. So as you know, like I'm still working from home here and MakerBot, we're doing that still. And they are all just incredibly easy to use, right? Some of them will require different extruders. You know, we have extruder 1 for your sort of low temperature polymers, extruder 1XA for the higher temperature polymers, say ABS, ASA, polycarbonates, and the like. Then we have the Labs extruder that will cover your third-party materials, and of course the support extruders, right? But you know, we have launched quite a few new materials in the past year, anything from the new nylon carbon fiber, nylon 12 carbon fiber, which is still my favorite. Well, now metals is competing for that spot, right? So the 31L stainless steel, it's really something. We'll talk about that later. I mean, we've already had quite a few chats about the metal itself, or specifically, and then you know, a range of others like the CEPS, which is rather interesting because it's flexible. But if you have any questions about the materials, you can just go to our website, makerbot.com well, actually here is a full URL, /3D printers /materials /method materials, or you can just click materials here on the top nav, right? So you click materials on the top nav, that takes you to this page, and then within this mosaic, you can actually choose each of these materials and see, you know, their different mechanical properties, download the data sheet and whatnot. I'll jump back now to my setup here, and I'll be talking about quickly and briefly about the range of materials that I have here. So I have this first sample. This is actually an STL from NASA. You know, it's the actual crater where the rover just landed. So yeah, I'm blanking out on the name of it. But I was printing this out just like a quick test of the layer resolution that I can get with the method. This is ABS, but even with ABS for having sometimes shrinking issues, but with the method you just see like really nice layer quality. I'll try to bring it as close as possible to the camera. Maybe it'll focus, I'm not sure. But you can see how smooth the surface is right here, right? So this is a quick test out of the roughness. This part was actually printed on the side, like so. There you go. Kind of to get as much resolution as I can. But you can see like both the valleys, the peaks, they are really nicely defined. So ABS here. Then jumping onto my first labs material, which is CEPS. This is flexible. We've been having interestingly, a lot of questions after the release of metals around whether we also have flexible materials, and we do. So this is our CEPS material. This is actually from Jabil, one of our partner, well, a company we've worked with a lot in developing new materials. But yeah, you can see, highly flexible here, like this demo tire that I've got here. Then of course, well, I'll start with the carbon fiber. This is nylon 12 carbon fiber. Nice part for a new case study that's coming up in a couple of weeks now. Support material, this white element is actually SR30, our water soluble support. That's from Stratasys. And finally, these two parts here show our new metal composite, right? So it has the same, well, I'm playing here with stainless steel, so the BASF 3116L for both the gear here and this pipe. Always satisfying to hear that metallic clinking noise. And then this sleeve that I printed out for this gear, it's actually just meant to be, helping me with the attachment of this into my assembly. I'm still working on this. But yeah, the point being here that I've used the same printer to print carbon fiber, ABS, CEPS, and metals in the same platform, right? And the thing that actually enabled me to do so are the modular extruders. So let's talk a little bit about the extruder itself. The extruder, it's essentially what the last element that will touch the, oh, sorry, blurring out a little bit. Come back. I don't know why the camera's a little bit blurry now. I'll jump back and forth. There we go. So the extruder is the last point of contact of your filament before it actually becomes your part, right? In this case, I've got here extruder 1. Extruder 1 is supposed to feed our lower temperature polymers. Think about PLAs, think about nylon, PETG. And here I've got the Labs extruder, Gen 2, a brand new Gen 2 Labs extruder. I'm going to do the quick unboxing session, of course. Quick cardboard cover, and then the bottom line of today's talk is the actual elements that come with the extruder itself. So I've got the extruder, right, nicely packaged here. I'll just put this back to the side. The extruder itself, it's fairly similar outside, from my regular extruder. However, it does have an extruder tip, exposed tip. That exposed tip is what's going to be allowing me to change the nozzle, right? It's not possible to change nozzles on the regular one extruder. The reason being is that we don't expect you to be servicing this one. However, the Labs extruder, since it's meant to be used with a range of materials, you can encounter different issues. If you're using third-party materials, we want to give you the option to actually access it, open it up, and maintain it. And not only that, but also we include a few things here with the Labs extruder. I'll just put this to the side, give myself a little bit more room. But a few things that are included with the extruder itself are, first of all, this guide tube. This guide tube is meant to be used actually to route the material through the side of the printer so that you can use a third-party material that's not, inside of the machine, so inside of the drawer case. Then we have a small hex key that is actually what will allow us to open up the extruder in just a second. Let me clean up my mess here. So the hex key. Next up, a really nicely designed additional key. This is what I'm going to be using as leverage, or actually to have the leverage on the extruder to swap out the nozzle. The second nozzle, right, this is the one that I'm going to be substituting in the extruder. And finally, the smaller PTFE section of the tube that is actually going to be hosted inside of my extruder. This is what routes the filament into the nozzle like so, right? So I'll be showing you guys how to do that in just a second. Now, jumping back into the extruder itself, let's say that I've been doing, and this is something that actually has happened to me a lot, well, not a lot, but every time that I change between, if I continuously change between higher temperature materials and lower temperature materials, I will start seeing issues. That's why I like it better to have dedicated extruders. Even if I'm using a Labs extruder, it's kind of cleaner to just keep one that's for metals, one that's for polycarbonates, just because of those temperature differences. You can definitely make it work and jump back and forth between materials, but I keep using the same metaphor, and I think it makes sense to me. It's just like a drill bit, right? You wouldn't have, even though if they are both 1/4 inch drill bits, you wouldn't use the wood one on concrete, and vice versa, right? It's better just to have, for the process, to have a dedicated tooltip for the job, and that's what essentially we are going to be doing. But let's say that you need to replace the nozzle here on the extruder. Step one is going to be to, of course, remove it from the printer. This is brand new, so there's no visible wear anyways. And step two is going to be looking at my set screw here. So this set screw here is what's actually going to be opened up by my hex key. You can see, probably can see, let me try to bring it closer to the camera. I actually have a macro lens here. I'm not sure it's going to work, but I'll give it a try. See that if it actually helps me. Oh, look at that. Not too bad. So you can see here with my new macro lens, which I'm just holding with my hand here, so it's going to be a little bit shaky. That hex, additional element in my extruder, that's the hex key that I'm going to be removing, right? This is actually, the matching hex key. Oh, much better actually on focus. I'm sorry, I'm just excited because I've been having some issues with focusing on the setting, lately. But anyways, I'll go ahead and open up my set screw, right? Here we go. It's just, a matter of a few turns. This is just meant to keep the nozzle in place. I don't need to remove it all the way, right? Just to loosen it enough that I can sort of feel that it's already loose and I can spin it with my fingers. And then once I've done that, here, using that macro lens again, just because I think it's actually helping us a little bit. So you can see it's just barely loosened up right now. It's not completely attached to the nozzle. And I'm going to go ahead and use now my secondary key. This is just my sort of leverage key. You see how I'll just mount it first and then show you guys the details with the macro lens again, because this is actually coming to be really handy, happening to be really handy. So you can see that there's actually a nice little notch on my extruder there that matches my my little lever, right? That lever is actually designed by us. It was actually designed by one of our designers, Andrew Askedal, and it's meant to essentially fit that element on the tip. I can just go ahead and pull it up, and once it's, I'm trying not to block the camera, so it might take a little bit longer for me just to pull the extruder out, making sure, the set screw is still a little bit too close for comfort there. There we go, this should be enough. And now, here we go. You can see how now the nozzle itself is completely out, right? So I've already pulled it out. And you'll also see now, jumping back, I'll just try to print a rig for this, because I think that this is going to be really handy for us to have these conversations in the future. It's just helpful to be able to focus deeply into those details, right? So you'll see first of all that the nozzle is now out and loose, right? I can just pull it in and out. And also you'll see here, as I pull it out, there we go, that plastic element, you'll see like those little, that little sleeve, right, that's coming out of the extruder. I'll just pull it really slowly so you guys can see. This element is actually the used portion of this guide tube, right? So this is the secondary guide tube, the replacement one that comes with the with the extruder to replace the extruder, or the nozzle actually. Removing the macro lens, putting it to the side. But I can now pull my extruder out. I would recommend trying to, and by the way, you should do this with the extruder completely cool down. Otherwise, yeah, you're not going to have a fun time. But I would recommend pulling it down, holding on to that little PTFE tube inside here with your finger if you can, and then slowly, there we go, pulling the nozzle out. So this is my old nozzle that I've got here in my hand. I'll put it in the box just to keep it tidy. And then this second element, the guide plastic tube here, I'll just pull it out from the side. Why am I pulling it out from the side? Just because it's going to be rather complicated to pull it from the bottom if I was to try and pull it the same way that I did the nozzle itself, right? So I'll just pull it out slowly. It's kind of tricky because of the space that I've got, but you'll see how it starts to come out to the side. And here we go. This is my last guide tube element. And I'll put it to the side. So let's just pretend that this nozzle was already worn. I needed to replace it. Maybe it was already clogged. And now I'm going to go ahead and replace it with the new one, right? So here's my new nozzle. It's not just a matter of putting or sliding the new nozzle inside, but rather first preparing my guide tube here, putting it into my nozzle. And it's already been cut out, so in such a way that you can just bend the excess plastic, which is what I'm doing here, kind of like this reverse bend. There we go. Just to give it a sense of direction for the plastic, so that I don't have to do this while the nozzle is inside of the extruder, right? And I'm going to go ahead and push it up the same way that I took out the nozzle in the first place. Oh, forgot to say that. Yeah. It's also a better idea to just put it in here inside of the extruder first, so that PTFE tube first, instead of trying to push it through that assembly. So I'll go ahead and guide it a little bit. Doesn't have to be exact because the nozzle itself is going to be doing most of the guiding here. I have the camera on my face, so that's not making things super easy, but here we go. Okay, fairly aligned. You can see the tube in there. I'll go ahead and push the nozzle up, trying to align it with the tube as much as possible. The tube starts to slide down. Here we go. And then trying not to cover that too much with my finger here. Just making sure that the tube is correctly positioned. There we go. Tightening it up. Okay. And you can see now the tube is in there. Bringing my macro lens once more. So the tube's in there, ready to be pushed into the final position. So I'm going to go ahead and just make sure that the little petals that are sort of protruding are now here. Also the key might come in handy actually, just to make sure that everything is falling down into place. So just giving you guys a detailed shot. Let's see if it's not too dark, but you can see how the plastic is now sort of fold back, right, and guiding my nozzle into the proper position. So I'm going to go ahead and finish up by pushing the nozzle entirely. The nozzle sort of completely flush with the extruder assembly here, right? So there's no real gap. Once again, macro shot. There's no gap there. Let me have that sort of focus here. But there's no gap between the extruder assembly and the nozzle itself. And once I'm there, I can just go ahead and take my key again and start tightening up my set screw. The good thing about this is that even if you sort of don't have the nozzle perfectly aligned, which you should, by the way, you should try to push it as much as inside as much as possible. But even if you don't have it perfectly aligned, the calibration process will take care of any discrepancies here. So that's also kind of giving me a little bit more peace of mind. Just tightening up the set screw enough so that I can no longer, without much force, make it turn. That's about it. Doesn't need to be like completely locked up. And that's about it, right? That's all there is to replace the nozzle. It's actually a really helpful process because of the fact that it essentially clears up your extruder. It enables you to start all over again and, you know, get printing with other materials in case that you needed to service up your extruders. With that, I'm going to start jumping into some of the questions that you guys may have. So, well, you know what? I'll leave this view here. I think it's going to be more useful for us to discuss with that view as opposed to just me and the printer. Let's see now. What happens if you print with a worn out nozzle? Well, I would say the issue, let me bring one of my more worn out nozzles here to the camera. Here we go. So this nozzle actually I've been using to print with nylon carbon fiber, and you can see that it's not necessarily worn. It's more like dirty. I would probably need to clean it off. The nozzle itself will hardly worn. You know, it's more the damage that might happen after quite a few hours, and we're talking about several thousand hours or hundreds of thousands of hours. It's going to be more in the internal components of the extruder. The issue with the nozzle, it's more around having clots, right? Having leftover material. So as much as it's happening here on the tip, it will happen in the inside of the nozzle where a little bit of that excess material that maybe, you know, got overheat and burnt, you know, slowly over time will start causing clots here in your extruder. So that's the main reason why you would want to change your nozzle. I've seen people mention filament cleaner and oiler. Oh yeah, what are they and do you have any suggestions? Yeah, I've seen some people say like, you know, you can use regular corn oil or canola oil. I wouldn't recommend it, especially for sure not for methods extruders. It used to be a thing with you know, extruders on more maker and hackery machines. I've used it in the past. It may help for the first, you know, couple of hours of printing, but it's definitely not the solution, right? It's ultimately the filament is running, you know, you're talking about just for a part like this, we're probably going to be running a good, I don't know, 50, 100 meters of filament. So it's so much filament that by the end of the part, you probably burned all of the oil, and essentially it all comes down to the proper manufacturing process of the extruder. I wouldn't recommend using anything extraneous to sort of maintain that lower friction of the extruder. It comes down to the tolerances and the accuracy that was used to build the extruder itself. How important are filament feeder cleaners? I think it's the same, you know. Well, I've seen it somehow in some applications. I don't really trust them. It's better to, you know, for me, it's better to rely on a good extruder and also to have some sort of dry environment to hold the materials at, right? In Methods case, we have the drawers themselves that enclose the materials and keep those materials at a really low humidity rate. You could also think about buying a side caddy for the material that will lower the filament humidity. That is what will make you the most different, not so much the filament, the feeder cleaner itself. How often should you clean your 3D printer nozzle? I would say, for example, this is a good example again, as soon as it starts to look kind of clogged, kind of like very dark or tarnished by the filament, I would do it. With Method, you know that I don't have the little brush here, but it comes with a steel brush that allows you to clean that up really easily. So I would say every time that you see it dirty, I would do it and then run a calibration because it definitely helps have you know, more successful prints. How can I make my nozzle last longer? That all depends on your use. As you know, the question before would suggest, the more better maintained that it is, the more lifetime you'll get out of the nozzle. The good thing is that, you know, with the Labs extruder, it comes with 2 nozzles, so that's always gives you some peace of mind. Stainless steel versus brass nozzle. Okay, all of the Method nozzles are stainless steel. Stainless steel is going to be a much more harder material than brass, so it's going to last longer, just naturally. We don't offer any brass nozzles anymore. We used to in the past with the Replicator series, but not anymore. Now it's all stainless steel, and so far, it's been amazing. How do I know if my 3D printer nozzle is bad? You could see some calibration issues. Specifically with method, I would say check on how the filament is flowing. It all depends on the model that you're using, right? But as long as the filament, when you're doing a purge process, it's flowing freely, then you should be good to go. Do you always need to clean the nozzle when switching between filaments? Yes, 100%. That's really important because of the fact that, as I said before, different filaments will have different melting points, and that will essentially cause debris to accumulate in the nozzle itself, which might stick if you're using a lower melting point with a new material. So yes, every time that you change materials, you should clean the nozzle. Actually, the printer will give you a warning for that, or suggest that you do, and it's definitely highly recommended. And I think that with that, we're coming to an end. If you have any more questions, make sure to send this out at either send us a note at hello@MakerBot, Felipe@MakerBot, I'm also there, or simply through our social media accounts at MakerBot, both in Instagram and Twitter. I keep an eye on those too, although I don't run them. That's Alejandra on the back end, on the scenes, behind the scenes. But as always, thank you guys so much for watching today. It's almost 32, half a year. Well, it's been almost a year actually. But in any case, thank you guys for joining today. I'm sure that we'll have more things to talk about in the next time. But for now, I'll see you next time. Have a good one.